In this video, we're going to go over 9.2, check and reflect from page 325. Okay, one thing I forgot to mention with 9.1 is when you guys are doing this unit, remember with this, we are using our filters. So you may see a lot of information in here that you may disagree with, but we will respect the opinions as always, but we don't have to necessarily agree with. The first question from Earth: why does the sun appear to be rising in the east and setting in the west? So if we were taking a look at a perspective from the North Pole, we would be spinning on a counterclockwise direction, and the sun would appear to come up from the east and set in the west. Number 2A. Explain the connection between the sun and the tilt of the Earth's axis in relation to the season. So we'll just say this is the sun, and sorry, this is a poor model, but this will be the Earth. We'll say it's the tilt of its axis. So right now, if we were in the northern hemisphere, this would be spring for us. But as the Earth rotates around the sun, it keeps its same tilt. So at this point here, this would be summer for us. The northern hemisphere is pointed towards the sun. As we go around, it'd be fall for us. And over here, winter time. So you can see the bottom of the pen, which represents the south pole, it would be closer to the sun. So that would be the summer for the south and the winter for the north. And then we come back over here. It's spring once again. Okay, 2B. Have different cultures detected these seasonal changes? Yeah, absolutely. Numerous cultures have obviously observed different seasons over the millennia. Recognizing the seasons was extremely important for numerous cultures, knowing when to plant their crops, know when seasonal migrations would occur, know when they had to get ready for the cold seasons. In some areas, rainy seasons. 2C, explain why this was necessary for their survival. Well, a great example is the First Nations people of Saskatchewan. So traditionally, if they could not recognize the seasons, it could be devastating for them, not knowing when to get prepared for wintertime. So a lot of the First Nations people developed different tools to help them observe the seasonal changes and predict when they occur. So many of them would use medicine wheels to mark the seasonal changes. Question number 3. Describe how the Northern Cree and Dene divide one year into seasons. How is it different from how Eurocentric cultures divide the year into seasons? In traditional Cree and Dene cultures, they actually divided the year up into 6 seasons, and within that they would have months based on the lunar cycles, so they would actually have 13 months in a year. If you take a look at the Eurocentric interpretation of seasons, which we commonly use, it sees a year with 4 seasons and only 12 months. Now, if we take a look at the Cree Dene way of dividing up the year, it does make a lot of sense, especially for those that are involved in agriculture. If we take a look at what happens on a farm during the year, you could divide up the year into definitely more than 4 seasons. So we could start off with winter time. Then we have calving time, seeding time, haying time, harvest time. Then we could actually have a fall, which it could be like bale picking and stuff like that. And then we return back to winter. So we could even have 6 or 7 seasons if we divided up by the way a farm operates in a year. Question number 4. Why do we only see one side of the moon at all times? We only see one side of the moon because it rotates at the same speed that it orbits around the Earth. Question 5. The moon does not have a dense metallic core as Earth does. Instead, it appears to be composed only of the same materials as are found in Earth's outer layers. Based on this information, what conclusion can be drawn about the formation of the moon? So there's a lot of different beliefs with this. So the one that would be most common around our setting is it was created at the time of creation. Some people believe that a huge asteroid or comet actually hit the Earth, and the Earth or the moon was actually a chunk of the Earth that ended up splitting off. So there's lots of different theories and beliefs. So take a look a little bit at some of them and just see what other people think. Okay, number 6. Sketch how Earth, the sun, and the moon are arranged on a night when we can see a full moon. So on those sketches that you have, you should show Earth directly in line with the sun and the moon. Question number 7. What is an eclipse and how does it occur? So an eclipse occurs when the moon, the sun, and the Earth line up with each other in a way that a partial or total shadow of one of these objects is cast on one another. Number 8. Describe the different types of eclipses that can be viewed from Earth. So we have 2 different eclipses that we can observe. One is a lunar eclipse and the other is a solar eclipse. A solar eclipse occurs when the moon lies directly between Earth and the sun, blocking all or part of the sun's light. A lunar eclipse occurs when Earth blocks out the sun's light shining on the moon. Earth casts a shadow on the moon, totally or partially. Question number 9 asks, do you agree or disagree with the statement, a total eclipse of the moon by Earth can happen only during a full moon? Justify your answer using a diagram. During a total lunar eclipse, the moon must be on the opposite side of the Earth from the sun. If the moon were not in Earth's shadow, its surface would not be fully illuminated. Your diagram should resemble figure 9.21 on page 320. Question 10. The sun is a star. Use your own words to write a scientific description of a star. So in your description, you should include that a star is a body of plasma or electrically charged gas, which emits energy from nuclear reactions that occur in its core. Number 11. The sun features significantly in the traditions of the Saulteaux people. Describe one understanding that Saulteaux people have about the sun. An example is that the Saulteaux or people believe that the sun travels across the Earth's sky, so that the sun is revolving around the Earth, not the Earth around the sun. This spiritual-based understanding coexists with a scientifically based understanding. The two don't contradict each other, so it's a great example of people being allowed to believe and understand their own beliefs. Question number 12. What is the solar wind? The solar wind is a flow of electrically charged particles emitted by the sun. 13. Name the solar event in each image. A and B below and explain the cause of each feature. Okay, so 13A, that would be image A, it's a prominence. These are arcs or loops of gas that have erupted from the surface of the sun. Image B is a sunspot. A sunspot is an irregular dark spot that appears on the surface of the sun. Sunspots are cooler in temperature than the surface of the sun and appear in cycles. Question number 14. How can a coronal mass ejection from the sun cause damage on Earth? A coronal mass ejection is an extremely powerful solar flare. These flares have a lot of magnetic energy, so if they reach Earth and if Earth's magnetic field is unable to deflect the energy can cause damage. They will affect many different forms of technology, including satellites, electrical transmission lines, and computers. We have a couple of examples of that have happened in Canada, and I believe in the mid 1990s, one mass ejection actually took out all of the power in the province of Quebec for approximately 8 hours. And in the early 2000s, another mass ejection ended up taking out a major communication satellite for Canada, knocking out a great deal of our television channels. 15A, explain, excuse me, according to scientists, what causes astronomical phenomena known as aurora? The aurora borealis occurs when high energy plasma emitted from the sun interacts with Earth's magnetic field. B, why is it important to continue to study auroras? Well, auroras are caused by solar flares, but Earth's magnetic field reflects the flare, creating the aurora. Because they are solar flares, they can do damage the same damage as a coronal mass ejection. Question 16. First Nations and Métis astronomers used their own observations and cultural perspectives to explain celestial phenomena. Describe some examples of how First Nations and Métis perspectives differ from those of scientists. There's numerous examples that you could pick from. Some Nakwe believe that the sun revolves around the earth. Some First Nations and Métis people talk about how the Northern Lights, or describe them as spirit dancers, pone spirits, or spirits of family. Sometimes the colors will represent different things. So if the lights are red, then there will be bloodshed.